This is Suraj Singh and I'm showing you certain drawings. Long background. This is L-shaped tower portion of a building, and also you can see two plans in this. Columns are shown, grids are shown, plan is shown. For structural guidance, elevator is also shown there in that. This is this was drawn in 93, 94, 92, like that. Purpose is to tell all this because elevators are shown in this, and also various grids are shown completely. Once again, and I'll go back. I'll take other one by one. And another drawing. This is cross Rex shape. This is also same lower and tower portion. Lower terrace and tower portion. Show you as much as possible. Back. Take this one back. Now it's another one. It's I, and typical one is I. Other building, I other building. Another one. This is a part. This is about a shape of flight, shape of plane, details of that. Another one. The structural profiles, actually these are structural plan profiles. Just generally grids have been capped 5 meters both ways generally, and this is commercial building. Whatever it is a shape commercial building. This is A, shape A, letter A, commercial building, part of India Beautiful Nation, district center, lower, lower floor and tower floor, both are shown in this case. In this, actually, columns, elevators, bank elevator bank and columns have been shown, and also various areas, structural planning, can you say, or multi-story or high-rise. This is schematic only, not worked out further. This uh, the one. This is T-shaped similarly, a part of nation, is a part of India, beautiful nation. T comes in nation, so it's down, lower one and tower one. Structural material, the structural plan on grid base is shown, and that also in this are shown elevator banks, columns, grids, and 15 meters total width of ladder. So I take off this as well from here. Maybe I take another one. That is it's U shape. Yes, U shape, same way. Beautiful, part of beautiful, U, beautiful. It is U, a part of beautiful. As I told before, that was a plan in that city, that is just a center plan, and shape was India a beautiful nation based on secularism of our country. It is our constitutional mandate. At that time, I didn't know constitutional mandate, but it doesn't matter. We are secular people by heart and by mind, by body, and this is the D, part of India, India. D, lower and upper one, part of tower as well as part of below floors. And it's also same solutions, elevators, bank, elevator bank, and grid showing all grid arrangement. I think it's O. Yes, it's O. Oh, it's O. No idea. It's O. One second, I'll show you. And hold it back. This F. Beautiful. Part of full. Beautiful. F. F. Beautiful. Part of beautiful. F. Yes. Maybe you not see such drawings these days. Luckily, I have this is a part of my archive, of course. It's personal archive. You will not find this anywhere. It's computer world these days. And this is FE, E from the same BEA, beautiful part of beautiful. This is E, letter E, same provision, same style. Let me see. Let me go back. Then we got folded actually. And this is B, beautiful, first letter, beautiful. I'll take it now. There's curves in this. Curves and elevator bands and it's a little complicated of course, but what to do? The letter is that. To do the hard elevator. I'll go back to oh, it's not for actually it's for the tricky stuff. We found to handle this drawing is problem. This is A, A as this one is a part of A as well as beautiful. India, also in India, it is A, then B-E-A-U-T, beautiful, the nation. This is for four locations. A, also in India one, A is there, and beautiful is there, as well as nation is there. So this is a dominant letter in that place, and then working. This is D. This is D. All right. The next one is let's see which comes. N. This is N. Part of nation, part of India. India, there's N in that. Nation, there's N in that. So this has two locations. Typical building in two locations, except height. Height may vary depending on how many stories we consider in one letter, one word. Nation. higher tech in India, it could be Bharat as well. So little change will be there in that case. So, so F E and one building, another building, and then community centers. There's a then nursing home. Three buildings are shown in this. Three buildings are really. One is letter E E. I told you right. One is letter E. Other is U shape. Nursing home and community center. Three three plants in this. Three plants in this. You can see that. This community center and this U-shaped nursing home is included in every complex. There are so many regulations, and this is now a police station type, and other structures are shown. I'll show you. Okay, I'll show you just this one. Common structures. Down to the next one. That's that. Another plan of detailed one for the building. Yes, this is 7, 8, and 6. Ha ha ha. 7 and 6. Three letters. 7 and 6. One. Another one. This is cross. QC point. And you see this one. This one otherwise no problem. And this is like this. one structure. These are locations of column grids, you can say layout, structural layout of that building in concept terms. So, or terms, technical terms, you call it structural layouts or floor layouts, structural floor layouts. And this is swastika. Swastika. Shows this way. And down. This is the other one. This is now yeah, this is continuing building of piston shape. Piston shape building. Sorry. Show differently, okay. So, pattern for a book. Going to show down. So this was one. Here it is. This is another building. Carport. This is carport structure. Carport as usual as enclosed on those integrated plans. This is tower. Maybe it's not clear, but this is high-rise or multi-story carport. One side is entry, one side is exit, and there is coverage given within is about 80 meters by 80 meters, not less than that, more than that maybe. This is actually, you see, yes, 85 meters, 90 meters, yes, around that. And this is the reservoir. I'm going to show you. Reservoir stays 10 okay. This tank of reservoir. And there are other details as well. Instead of this stair details as well as the one. This is the one. Next one is this is a series building. You see that? This is different type of shape in sequence. Gives a different type of architecture. Means new type of structurally produced architecture, not direct architecture. We have to use structures to produce elevations, external elevations, as well as internal type of design architecture. Both can be produced like this height. Then now, similarly, the same one with different things. It's lower roof and first. Okay, this means I just have different floors of different floors of same building. And it means just keep in mind that these were drawn in 92, were drawn in 92, 93, probably 94. In those days, these were drawn computer program. In those days, pencil and rubber and scale and so on. So, I'm just trying to depict you working in those days. Now, what is very simple for manual work only. And this one is R, Q, and R. See, these are buildings in shape of Q and R. Let's shape Q and R. Q is there in one shape, Q is there, and R is also there in that. So, and R also. So, this is one of those complexes. I've showed you more than 40 complexes in that city. Only few are left. Maybe friends, few are left now. This is okay. This is K and L. K and L. This side is K, and this is L. And the detail of both one. See this detail as well. I'll show you the one. This is P and O. P and O. Letter P and letter O is move. And this is M and stair. You see this big M. And this is N, which is general. Yeah, that's the other one. That's it. This is A and B. That means A and B. You can see the details of each flat apartment in both technical details are shown in every plan, and also various other details are shown. And this is D and C. And one is D and one is C. Same details of type of apartment or dwelling unit. And this is F and E. F and E. One end is F and one end is E. And typical details. Understand? I and J, I, J, I and J, one line and a J, and you can see is separate layouts. The last one in this range, and this is yes, there are many details in this. Of course, you can say this is G and H. G and H. Okay. Yes, good morning, Suraj Singh, civil engineer speaking of other NCR, Bharat, India. I just tried to show you various plans which were drawn more than 25 years back, or more, say, when there was no computer. These were just drawn for sake of township. Then nothing happened in those days. I'm talking about this practical book of civil buildings as I continue my talk. This was also done in those days, published in 96 and scripted in 92 to 94. This gives just how to work in field depending on in line to I used to work. And this is just a practical book, not involving any theory or any studies as done in colleges and universities. Just it's an attempt to reflect for those who are in field but not aware of practical works. I had talked in this book about practical management, field management, which parties are involved in there. Generally, we know that there's a person or a party called employer or owner or promoter, and there's another party called contractor. That person constructs project. It may be design and construction or only construction, and there's another party called engineer who supervises that, designs that. So there are two contracts. One exists between employer or promoter and engineer, that is called management contract, design and supervision contract, and there's another party contract that is called owner and owner and contractor. That contract is construction contract or EPIC contract, both, in which construction of project is done delivered by contractor as party 2, and employer or promoter finances everything and takes liability and responsibility of that project. So both are involved in that. That is called construction contract or design and construction contract or EPC contract. When it is construction contract means it is purely construction contract. Details are provided by engineer, design engineer, and supervision is also done by engineer on contractor on behalf of employer is promoter. So there are two contracts in this triangle. One is management contract that exists between employer, promoter, and engineer, and other one is construction contract or design and construction contract and exists between employer and contractor. This is the basics behind this. So if you are in contracting company, you have to act that way. As I explained, roles of those people involved in construction. And if you work in designs of the engineer, you have to supervise, you have to involve in designs, you have to involve in submission, providing all details, technical details and contractual details to contractor on behalf of employer. And employer is independent in a way that employer is responsible for complete liability, financing, and everything. Whatever is done by contractor, whatever work is done, employer has to pay to that one. And similarly, employer has to pay fees to engineer or supervisor, whatever you can call. This is called construction triangular management or management on one side and construction on other side. Both are managers. One is both are expert of its own. Both are having responsibility according to their functions, and that is what is try to disseminate with people who are new in field and who are not well aware about this. This is of course a complicated management because it involves technicality, engineering, and technology. It involves commerce. It involves contract. It involves many other inputs. There are various other parties who support these parties, and those parties are these. These are, for example, support of quality, support of safety, support of planning, support of many other vendors, support of suppliers, support. Yes, there are very other stakeholders on that project. Basic, all are stakeholders. In fact, main stakeholder is your employer, financer, promoter, and other stakeholders I told you. And this is all made made integrated in charter of project. Maybe charter is new term for you people, but actually means rights of everybody, obligations of everybody, duties and roles of everybody. That is called a kind of charter. Means whatever is required by contracting or by designing or by whatever, you have to dispose your role, and that is very important. That role. If you cannot do that, you cannot function. This is not imaginary work. This is not a speculative work. You have to do. You have to use natural resources, natural products such as limestone, aggregate, coarse aggregate, fine aggregate, cementing materials, water. You have to combine all these into your product. That's called structure. Structure can be building, it can be whatever else. It can be oil plants, it can be oil, whatever. Everything natural products. This means we are taking out materials from mining and inputting into that structure. So on one side, we are impacting upon ecology, we are impacting upon environment. On the other side, we are developing something. Both are there. But best development is if you do best. If you cannot do best, you are not using natural resources to an optimum level. You are harming nature. You are harming earth. Your material which you are taking must not be wasted. It must be used with defined life of that one. Well, that is another point. My view is that I talked of roles of these people, that if these people, these parties, as I explained, work according to requirement, they benefit whole world. It's not limited to one country. It applies to whole world because we are living on this. And work is done everywhere. More than 70% works go into, more than 70% finances of work go into development works. This may be building development, road development, infrastructure development, pipeline development, or atomic reactor development, industries development, factory development. Whatever development is there, most of your money goes to such kind of construction projects. And construction projects are such that cannot be used only for 1 year. These are meant for decades and centuries. These are not for one day or 1 month. These are for many generations to come in. So we have to be very serious about that. It's not simple computer you change after 5 or 10 years. It's not a car you change after 10 years. It's not your mobile you change after 3 to 5 years. It is something that is going to be used for many multiple generations to come. So should we not be serious about that? Should we not consider this profession a different way? Should we take it for granted like other professions? Today there's a change in technology. Okay, I say I don't use this computer, I use another computer. I don't use this technology, I use 5G or 4G or 3G. There is continuous development. But in this case, in case of construction engineering, in case of civil, electrical, mechanical input, it goes for long terms, and that's what we call durability of project. And there is a definition which is mathematically based. You can say reliability of project. So reliability applies everywhere. It means it should be safe, it should work, and it should live long. Do you get me? Reliable means what? Work should be safe, it should be serviceable, give you service, and it should move long. Just like we say, live long. We say, oh no, long live, and long live. We just bless someone. Long live your life, long live this and that. So long live your project means long live your money, long live your life efforts, and let your generations to come enjoy that product. Is that something wrong? Means you can dispose car next year, 3 years, 4 years, 5 years, television you can throw off and all that you waste. You can buy another one. But can you buy house every time like that? Can you buy road? Can you buy airport? No. These have to move for decades, and that setup should be kept in mind. And moreover, current developments are moving in a very, very extraordinary way. Even many countries are now awakening that don't spoil your materials. Just like European Union says, do not throw your mobiles just after use of 3 years. Use it for 5 years, 10 years, buy repair, buy something. Elongate it, don't throw it. After all, it affects the environment, it affects your ecology. Ultimately, it is plastic and it comes from byproducts of petrochemicals. Where for some methylene, propane, methane, from where do you get it? Have you ever thought of? You say low density polyethylene, medium density polyethylene, high density polyethylene, then methane, then ethane, then propane, then this and that and that and this. From where do you get it? You get it from petrochemical products. When you get from sea raw material and then you extract, refine that and get your petrol, diesel, etc. What is balance? What is the remainder is byproduct. And from that you can get plastics. So plastic is nothing but hydrocarbon byproduct. This means a part of pollution. So as much as you use it, better. For example, polythene bags we use. If you use same polythene bag 10 times, 5 times, you can save environment. But what we do, we take it and throw it. Use it once and throw it. If you use it 5 times, at least you can save something. If you use as much as possible, if it's not wet, it's not spoiled, you can use, keep hanging in your home and use it, go to market, use it. That way we have to think. Time has changed, environment has changed, world has changed, ecology has changed, but setup has to change, mental setup. That is very important. This means we have to prolong everything. Forget profit now. Profit has gone, but these countries will not accept. Gulf will not accept. GCC will not accept. Middle East will not accept, and Europe also will not accept. No one will accept their loss of profits because they are living for profits. But question is not profit here. Question of natural resources. If you are not going to live, what's meaning of profit? If you are to die with cancer, you die of cancer or something. If you cannot live peacefully, what's meaning of that? So I was just talking of that because everything is interlinked. You cannot say that I'm talking of construction, I'm talking of that. No, it is linked. Construction directly linked. If you just, I just bring to attention that a bag of 50 kilogram of cement, OPC, which is called ordinary Portland cement, which is very dangerous for ecology. This 50 kilogram of bag releases in reaction with other materials, sand, water, etc. 46 kilogram of carbon dioxide, one bag of OPC, ordinary Portland cement, and if we use that long before. Now also people are using that, but they don't take into their consideration that they are harming air, they are harming environment, which we have to release. We have to get back in form of air and respire that, respire on that. So not only we are harming environment, we are harming our internal body, internal pieces of our parts of our body, which leads us to suffer from asthma and blood pressure and cancer, etc. We have to think integral system. It's not separate in isolation. It is we are also part of ecology. So we have to think now. Time has come. This is a part of real management. It's not MBI I'm talking. You're talking. It's not commerce. It is existence, survival of human being. If you just think, okay, let it be as it is, if you plant some trees and problem is over, no problem is not over. Air has been polluted to an extent, even trees cannot help you. Sea cannot help you. Sea cannot take more than 25% of carbon dioxide. It has also limited. It's going to produce more dangerous fuels because of fossils. So, what I say, I'm talking of construction, but this is linked to all fields. So, we have to improve construction, we have to search out better use of material, we have to search out better use of producing such material where if you live in, you enjoy life, not deteriorate your life, not harm your life. So, I would say I was talking till today about construction materials and construction use supervision. I have talked about how management is done, who are parties involved, how organization is done, what is organization of engineer, what is organization of contractor, and what are organization public, and how they act, what are various roles of these people. That I had discussed at length. I have discussed till now. And I was also discussing about various contracts. It's like I have discussed with you what sort of contracts are there, how this must be done, where we stand, how we stand, how quality safety must be added, because in those days there was a system when I was young and I working on this book. In those days, safety or quality criteria were of course done in field but not documented as it is done now. I was talking also about activities of building structures and swimming pools, which is also the major item in buildings. And yesterday I had discussion of swimming pool, which I had continued. I'll try to continue that one because that is very important part. Though it is very old, yet it is useful. It is useful in a way that I have taken up to some sort of Hmm. I guess we were asked, yes, commercials and filter series I was talking about, and yes, filter tank I had talked about, distribution system I had talked about, backwash control and recirculation pumps I talked about in that, and I have shown you, filter rates and filter and what filter is, and I showed you sketch. I just reminding I showed you the sketch here, which is for filter and tabulation is there in properties of that. I This is a and one side you see is a media filter media, one side this is filter media here, various grading of filter, graded material, and this complete technical setup sections how it works. I explained you the amount it was property of this. Now I'll move further on that. You can refer to last video, and this is also complete detailing of this. You can see this one, complete detail of that one again, and then there's another one. This is this detail. This is for same and description etc. is given. This is series of that, and now I'll move further. And for information, I'm taking all this from J2G catalog. Now I'll talk about for this filter, I'll talk about installation notes, some installation of that. And this filter, I'll just start from here now because pause them. Now, when you plan something, in planning your filter installation, considerable attention should be directed to foundation. Concrete should be of sufficient strength to support weight of installation. System, of course, should be located as close to pool as possible or below deck level. This yesterday I discussed, so just for overlapping I'm giving you so that you will correct to last one. Your location preferably should be in a filter room, or if it's outside, a dry and shaded area is preferred. If you are using a filter room, it should be dry and well ventilated. Consideration should be given to waste some and proper drainage. You should also consider location of various types of other equipment such as pump and motor, chemical solution tank, chemical feed pump, chlorinator, chlorine cylinders, exhaust fan, etc. All equipment should be easily accessible for servicing and winterizing. Pumps used with these filters may either end suction centrifugals or self-priming centrifugals, and end suction is suitable for installation below pool water level, while a self-priming pump is necessary for installation above pool level unless you have provided for priming. Now, to avoid water surges which may disrupt media structure, to avoid water surges which may disturb media structure, make adjustments in valve settings slowly and stop motor prior to changing filter from filter position to backwash setting and vice versa. Electrical wiring to controls and motor must be done by a competent electrician in accordance with local electrical code. Rotation of three-phase motors must be checked by a momentary start, stop and comparison of shaft rotation with arrow or pump case. Close attention should be paid to pump and motor installation and operating instructions as well as those for installation of filter. Now, initial operation, filter must be filled with water from bottom to top. Filter must be filled with water from bottom to top by means of gravity or through a circulating pump in order not to modify position layers of filter media and facilitate exit water throughout. So this is sketch I show you for reminder of the section to the sketch. This is the section of this filter which I just show you again show. No problem for that and go back. Other one. Now is a table and this is giving overall dimensions of this model. This is table here, all table. It just refers to what the dimensions of this tank in form of ABCD, ABCD, all that is given in this figure. You will see this numbering here, letter numbering is here. If you see, that one you will find here A, B, C, D on right side of this. You find that dimensioning. You can see that ML, all that is given there. This is in table. Mentioned like that. So you can accordingly. The description is pre-assembled filter unit for small to medium pools consisting of fiberglass resin base, FM series filter, single phase, PH series thermoplastic pumps, PVC fittings, quick fit connections between pump and filter, 1.5 inches valve and pump construct. So filter media included. Now I'll move to this one. Now this is filter and pump performances and recirculation pump series. Now this is sections. This is filter pumps. These are pumps here. These are installed one. The plan. This is plan. You can see the plan of this pump, and this is your elevation section. What do you call it? This is shown as property bases are here. What properties given is filter and pump performances are indicated here, and it's no use to read that. Means it is from catalog. You can also get catalog, and these are recirculating pump series. And there's a description here. I'll give description because catalog has got meaning now. I'll say this one. Filter and pump performances are given. Actually, I'll just tell columns in this. Model number is there, pump, then HP is given, then kilowatt position is given. After that, filter reference is given, then sand how much and gravel how much, and filter area is this much, filter rate meter cube per hour per meter square, then pump capacity meter cube per hour, minimum backwash rate meter cube per hour. Like that, performance parameters are given and sand and gravel etc. are given. So we'll go to the description. Description is of course overall dimensions are given that I just showed to you that you can refer. Now description is Jacuzzi series PH pumps are constructed of molded fiber filled in norile for corrosion free operations. What it says, PH pumps are constructed of molded fiber filled norile for corrosion-free operation. Design maintains isolation of water from metal parts of pump or motor. So this is norile, which is fiber-filled norile, so that it remains corrosion-free. Now it's a self-priming centrifugal pump with 6 inches pre-filter, including transparent lid and molded strainer. Now there is another one. This is all pumps include closed-type impellers of molded material, leakless mechanical seal, and brass pump shaft. Now, series PH2V are two speed pumps, 2900 to 1450 RPM means revolution per minute, single phase for energy saving, Whirlpool SP application. So these parameters are given. Apply these parameters I show you here. You can see these are parameters of this. These are very old, not new, but for information, you can just refer to that. There's nothing you can go to advanced one to updated one, and you can see factual one there. These are just for reference, for information. Now application is series filter pump should be selected to provide proper capacity at a total head developed by suction lift is the dependence on suction lift, then pressure drop across filter media, about 5 meters of water column, and pipe friction in suction and discharge lines. More than 4-meter lift or friction in suction line is not recommended. Normal operating head of pump on a sand filter is between 8 and 13 meters. Maximum water temperature installation is 60 degrees Celsius. This is maximum water temperature is 60 degrees Celsius. A control box with motor protection, circuit breaker or fuses must be installed for each motor. So there is a performance curve. Table is given a performance of this motor. These are tabulation of performance curves. Model number is given A, B, C, D, E, F, G, H. So this is show. I'll show you the curve here. The above data are indicative only. Then go here. Most activities of curves here. Curves either curves, performance curves, curve. This is characteristic and their language performance curve actually. So they curve performs, they call performs characters in their language on what's that. So these curves are here, and what it says I'll let you know. It's saying that, well, it's very small font here. Well, no problem. You can see that yourself. Then their dimensioning is these dimensions of pumps are given. This is a dimensioning of pump. This is a projection of pump in elevation, and suction point is shown in this dimension F, D, E, G, etc. which are taken from table. Similarly here A, B, C, D, this is shown here, and you can see this performance here. I cannot read it well, no problem. So we go to, and this is view of pump, photo snaps of pump. What it says now about this description is PC pumps are constructed of molded fiberglass. As I told you before, caution-free operation of that PC centrifugal pump. All pumps include closed-type impeller and molded. So same thing is there. There are two screws and all that. So this is same model, same thing. Now application, same application. Various types of pumps and curves are shown in this. Again, the same. Different type of pump is there. Same performance curve. And this is different type. Various tabulations are there. Dimensions are there. This is shown in this. Then this is another one, same of different design. Recirculation pump is found, and then same description, performance table, application. So a typical movement is there. So we have to cross this and see another performance level of this. Another type pump is here. This is this type. Overall dimensions and performance. This vary from one pump to another pump. And we go to other one. Yes, automatic pool skimmer series. Now I am going to this one. It's different. Different tool. Automatic pool scum series. Now this one. Automatic pool skimmer series. Skimmer this is no. This is what it says. Now it says this series FM skimmers are constructed of white thermoplastic moldings. That's called ABS, white thermoplastic molding, which are heavily ribbed for strength, heavily ribbed for strength, and may be cast in as part of concrete pool wall. Accessories are available to allow use with vinyl liner or fiberglass pool wall. Once again, you see this because this is some construction of this structure of this is mentioned here. So it's a molding. And it mentions that these skimmers are constructed of white thermoplastic moldings, which are heavily ribbed. Ribbing is shown there for strength and may be cast in as part of concrete pool wall. Accessories are available to allow use with vinyl liner or fiberglass pool walls. Now, model is shown. This is a basic skimmer, then a skimmer with balancing valve, and then basic skimmer with overflow outlet 1.5 inches dia, and a skimmer with balancing valve and overflow outer. So just see what it says here. Four types it says in table. Model is given there, description is given there. As I said just now, basic skimmer with balancing valve, and basic skimmer with overflow outlet 1.5 inches, and skimmer with balancing valve and overflow outlet 1.5 inches diameter. And we can say we go further on this to see what it is. This is section of this. This is section of this. How it fits in there. This is section here first. See that one. See closely. This is very important section. The mentioning is there. Number one is intact lid. Two is weir. Three is strainer. Four is valve. And these are 1, 2, 3, 4 written here. Once again, you can see that intact lid. Two is weir. Three is strainer. Four is valve. You can see there two. One is on top. You see intact lid. Then two is weir. Then three, as it said, three is strainer. This is strainer here, and four is valve. This is four is valve. So this is here, and from main outlet, this is written here. It enters in. See what it says: accessories for skimmer. Throat extension model used with liner or fiberglass pool allows skimmer to be located 18 cm away from pool valve. Face flange model, this plastic used with liner or fiberglass pool allows watertight seal between skimmer flange and pool valve by use of bolted flange. Skimmer to the hose adapter. Skimmer to hose adapter model, this allows pool vacuum hose to be directly connected to pump outlet opening of skimmer. A complete skimmer includes, as I said, mounting ring with deck lid, mounting ring with deck lid, weir, strainer basket, balancing valve, equalizing outlet, pump outlet, overflow outlet, trimmer valve. So this is text here. I just read it again, just for information. It's text here. It says a complete PM skimmer included. Mounting ring with deck lid, 27.2 centimeter diameter. Ring is adjustable to match exact deck height. Lid is twist locked to ring and secured by screw. Wear, flap type assembly, 20.5 centimeter wide, skims surface freely and continuously through 11.4 centimeter variation in water level. So water level is 11.4 centimeter variation. This means this weir works there. Skims surface freely and continuously through 11.4 centimeter water level. And strainer basket, large size, 18.3 centimeter in diameter. Balancing valve, a plate a plate type valve, as I showed you in figure, a plate type valve that is adjustable to balance flow of water taken by pump suction from skimmer, weir and main drain outlet. A special float valve will automatically shut off skimmer if unit become dry to eliminate loss of pump prime. This feature is optional. An equalizing outlet opening 1.5 inches for connection to main drain of pool. Flow of water is controlled by balancing valve installation with one skimmer only. Pump outlet opening 1.5 inches for connection to recirculation pump suction. Overflow outlet opening 1.5 inches located at normal water level for drainage of excess pool water. This feature is optional. Overflow outlet. Now, trimmer valve, small adjustable plate to restrict pump outlet and balance flow between multiple skimmers installed in one pool. Then it's another one. Application number 4, which I showed to you, number 1, number 2, number 4, 5, 6. Actually, it's another sketch of that. Isometric type sketch. As we talk, number 1, number 2, number 4, number 3. We had discussed this is it's a blown up sketch. Alright. Then application. Purpose of a skimmer is to promote surface. Skimmer. Skimmer means to promote surface flow across pool. To promote surface flow across pool. Additionally, drawing in water, which requires most treatment since it is continuously exposed to sun, rain, and wind. Water is continuously exposed to sun, rain, and wind. A skimmer removes floating dust. So when it's exposed to wind, means dust must be there, debris must be there, leaves must be there, oil must be there. You can say skimmer removes floating dust, debris, leaves, and oil films before they can accumulate on floors and walls. It also proportions water passing through filter between flows across surface and through main outlet. Furthermore, it provides a connection for a vacuum cleaner hose. Residential installations use one skimmer. Application I'll tell again because it's important. Purpose of a skimmer is to promote surface flow across pool. In addition to drawing in water, which requires most treatment since it is continuously exposed to sun, rain, and wind, skimmer removes floating dust, debris, leaves, and oil films before these can accumulate on floors and walls. It also proportions water passing through filter between flows across a surface and through main outlet. Furthermore, provides a collection of vacuum cleaner holes. Once again, you can see section. In section, I showed you all these four items. 1, 2, 3, 4, all these four items written here. This is section same. Same section details is here. This is detailing or isometric type. Detail sketch. This is a problem. So we continue now. Residential installation use one skimmer for 70 square meter of pool, 70 square meter pool, one skimmer and any part remaining thereof. So if it's 100 square meter, you might use two. Anyway, flow rate through skimmer is 1.2 meter cube hour. Flow rate through skimmer is 1.2 meter cube hour. I don't think it's too much, it's very slow. Maybe it's laminar type. Minimum and 12 meter cube hour maximum. So 1.2 meter cube hour to 12 meter cube in 10 times of that one. Maximum is that. So it's good. Piping for skimmer must be sized. Piping for skimmers must be sized to handle at least 50% filter flow rate. For commercial, this was for residential installation. For commercial is different. One skimmer for 45 meters square. This means there was 70 square meter residentials of 45 square meter pool surface or any parts remaining thereof. A flow rate through skimmer is 1.2 say meter cube hour minimum and 12 meter. So flow rate also shall remain same. Commercial or it doesn't make a difference. Piping for skimmers must be sized to handle at least 80% of filter flow rate. So this piping must be higher than residential piping. Use of equalizing outlet in pool wall is recommended. Equalizing outlet, there is one now given there. Now blow deck equipment is now important. Blow deck equipment. Main drain, blow deck is generally there in pools. So why it says main drain? Let me see the sketch is there. Sketch must be there. Yeah, there are sketches. Yeah, let me read it first. Now, this series main drains are constructed of white thermoplastic moldings. White thermoplastic moldings which are ribbed for strength and may be cast in as part of concrete pool bottom. We also talked this before. Design includes modern anti-vortex cover which snaps onto main body. Models are available to allow use with vinyl liner or fiberglass pools. Liner or pool bottom is clamped between two gaskets and secured to drain outlet body by 8 stainless steel screws. Models are available to allow use with vinyl liner or fiberglass pools. Liner or pool bottom is clamped between two gaskets and secured to drain outlet body by 8 stainless steel screws. Optional hydrostatic relief valves are available. Installation allows high groundwater level to enter if pool has been drained, preventing pool shell from floating up out of ground. Optional hydrostatic relief valves are available. Installations allow high groundwater levels to enter if pool has been drained, preventing pool shell from floating up out of ground. So this is preventive measures is talking about because pool can be uplifted by under water pressure if water table is higher. So the preventive one, the mod M20 concrete pools, dimensions of prefabricated pools. So concrete pools 550 dimensions. Now sketch is shown. The sketch is talking of. There are sketches here, figure 1, figure 2, and these are plans and sections for both. See that one here. This is sections of these schemes. So, so in section then For there is the dimensions is written dimensions for installation in concrete pool, and this also dimension installation prefabricated one. Now let's go to other one, that is, yes, this is other one. Concrete pool and prefabricated pool is another section here. Same way. And now sitting here, we'll see what is written here. This is column is model and pool type and outlet location, maximum flow rate, meter cube hour, size outlet, hydro relief. Well, I'm saying column means you have to take these columns and read in rows. Model number is given, pool type is given, then model numbers are there, concrete pool type, liner or fiberglass pool type, concrete, liner, fire, side, bottom, outlet locations are side location and bottom location. The maximum flow rate is 15 meter cube hour, 15 meter cube hour and 12 meter cube hour. And size outlets are 2 and 2.5 inches. This is general detail. Then inlet fittings. If inlet fittings are constructed of white thermoplastic moldings and available in three styles to suit all types of installations and flow rates. Few flow directions is adjustable up to 30 degrees Celsius. 30 degrees Celsius from center. I don't know what is the meaning. Flow direction adjustable to 30 degrees Celsius, wrong I think here. Director ball may be replaced with 1.5 inches. Plug for pressure. Testing of piping fittings have an outlet that is threaded 1.5 inches female and 2 inches male for optional pipe sizes. So another model is designed for concrete pools. It includes no leak flange with two mounting holes and a protection cap over face. So, now it says different sections here. Here different sections are shown, and you can see these sections. I think it's wrong. There's one section here, model IFL, and then it's different one, model IFA, and then this other one. Now what it says, this design model IFL designed for vinyl liner pool. It includes a face flange and gaskets that are clamped on both sides of a liner by four stainless steel screws. This design allows the liner to be removed without disturbing fitting. Two additional screws are incorporated to allow fitting to be pre-mounted on pool wall before that. Well, other one is designed for fiberglass pool. This was for vinyl liner. This was fiberglass pool. Includes a molded face flange, and gasket that are clamped on both sides of wall by draw nut. Installation quick, utilizing only conserve. Then there is chromed bronze wall fitting for concrete pools with gate capacity 40 meter cube per hour. Then chrome bronze adjustable floor and a 12 mm flange at you can see down here the wall fittings. Wall fittings are these. I believe this whirlpool fittings. Fittings are made of ABS thermoplastic materials. Water per air jet is directed by means of an adjustable nozzle, which has a 15 degrees movement in all directions with respect to horizontal axis. Intensity is controlled by turning knurled ring anti-clockwise to increase jet, clockwise to reduce it. Well, let's go further. Now, flow rate selection chart. Release your selection chart. Flow rate selection as usual. Previously, also I showed to many So this is for different equipment. Flow rates are given. You can see that model and type of pool, and then orifice size. Orifice, you know what is orifice? The maximum flow rate, and then recommended pipe is shown there. And of course, this is shown. I can read this small one. It says that, well, this table I'm not going to read now. Vacuum fittings are there. Now, vacuum fittings are constructed of white thermoplastic moldings and include a 1.5 inches plug that may be removed for insertion of HW15 hose to wall adapter. Installation features are same as series 1. So this is vacuum fitting. Other than rope anchor, both you can see. This is vacuum fitting, and this is anchor, rope anchors. This is written for rope anchors here. Rope anchors. That's written here. What it says, so vacuum fitting are constructed white thermoplastic. As told you, this is concrete type of wool is concrete pipe size 1.5 inches, 2 male, 1.5 inches a female. Then rope anchor, it says that constructed of white thermoplastic moldings with a stainless steel pin. It is suitable for concrete pool. And then go on to, this is lure type inlet. Lure type inlet fitting suitable for concrete pool, has female connection 1.5 inches to 2 inches with plugs. Length is 25 meter. Below deck equipment. Let's have a look on that. And this is light which I'm going to talk. Below deck equipments are there, So underwater, below deck equipment, underwater lights. Now this UL300 underwater light are construct the UL is standard one, UL300 standard you can take in quotes. Lights are constructed of white thermoplastic moldings and may be cast in as part of concrete pool wall. Models are available to allow use with vinyl liner of fiberglass pools. Liner of pool wall is clamped between two gaskets and secured to light niche by stainless steel. So light installation includes following components: light assembly complete with niche, that's 300 watt and 12-volt lamp and conduit. So this is light assembly deck box for connection between conduit and electrical service. Then transformer for underwater lights for 1.2 or 3 lights. So 220 watt, 220 volts to 50 hertz and 50 hertz 12 volt. This is transformer, or 115 volts 16 hertz 12 volt. A trim ring of stainless steel is optional. So once again I show this light. What specifications I just told you. This is that one. Can see this transformer and all that is there. And then we move further onto this. This is tabulation of this. This is model number, then description, voltage, outlet. So UL300C, UL300L, ST2, all this is shown in this. This is just tabulation of a property of light. So very simple, nothing explainable in that. And the next one, this is you say concrete pool. This is a concrete pool. Leave sufficient length of cable inside of niche to substitute. Now this is a section here. The section and fixing of light, fixing of strainer here. Both are here. Very complicated step, but useful. It's useful. You may not find that on your schematic drawings. It should be part of working drawing as far as I'm sure. This your contractor shall provide. This is just schematic sketch given from manufacturer of this item. But when you work in field, you have to make all actual drawings or working is called shop drawing or working drawing for coordination. And then after coordination, you can install on site. This is only the schematic one, not practical one. You have to see what you do on site and which type of light you select and which type of unit from surface diner or skimmer and others you take. It depends on that. So we'll move further to another detail of this. This is prefabricated pools. Above that are indicating only on that side. So let us say it's yours gives prefabricated one, same provision of here. You can see this only for information again that you should be apprised with means what sort of details you may find on those drawings of pools. Uh, Pool deck equipment, ladder. Ladders are constructed of high-grade polished stainless steel. High-grade polished stainless steel. Rails are 43 diameter. Well, they say 43 can be, that depends upon diameter. Seamless one-piece tubing. One-piece tubing. Seamless one-piece tubing. Treads are of skid-resistant design with stainless steel fastenings. Ladder assembly includes wedge, anchors and covers. Model two steps, 2L two steps, 3L three steps. So it says 2L two steps, 3L three steps, 4L four steps are available. And dimensions are, you can see the one on a small table here. So then this is a sketch of this ladder, stainless steel ladder, 2L, 3L, 4L, and it is shown 4L. You can see there are four rods are there, stainless steel, and two verticals. Dimension is there, concrete fill is there. So this is standard one. In those days, maybe now different. I cannot say. So this pool ladder. So it says handles for existing pools in stainless steel diameter. PVC plugs available in following types. Well, leave that. WHS. All right then. It's I-type support for handrail in chromed bronze for concrete pools with tile or plastic lining. So these are I-type supports for handrail. These are holdings. You can say I-type supports. They are since holdings. These are, well then, diving boards. Now diving boards are constructed of fiberglass with wooden support inserts. Top is finished with an anti-skid sand coating. Lux models utilize top-grade Kim dried Douglas fit alike them. Then standard construction is 2.4 meters. So let us see, it says made from AIS 316 stainless steel, complete with built-in handrail and non-slip fiberglass board. So what it's saying is that sketch is there and this is board, and let us see that one. Let's see clear sketch like that. This is diving board, diving board. You can see this letters are given and in reference of that you have to refer to table. That's what this diving board. So model says A, B, C, D, E, F. In A as dimension, main one total 240 and B is 75, which is projection from diving line is a projection. C is 165, there's concrete size, then D is 50 and 150. Once again, you can see the dimensions because these dimensions are here, A, B, C, D, all that, and these dimensions are here in tabulation form. So that's one. Now, safety and maintenance equipment, vacuum cleaning equipment. Well, these are very normal. You see yourself maybe using home. It's not very special. You all use in your homes. If you use, you know, or otherwise, no problem. These are all professional equipments, and cleaning is very important in pools from housekeeping viewpoint, detailed housekeeping viewpoint. So vacuum cleaner is designed to clean pool but bottom. Pool bottom means lower point, lower floor. which is having two levels and one inclined. Vacuum cleaner is designed to clean pool bottom utilizing filter pump providing water suction at cleaner head. Vacuum hose may be connected to skimmer outlet or to vacuum fitting in pool wall depending upon installation. So complete system includes a vacuum head, telescopic handle, floating suction hose, and adapter for skimmer or valve fitting. So the model is given and description is given, and in description is given vacuum cleaner head, stainless steel brush, telescopic handle, floating hose, 10 meters length and 15 meters length, hose adapter for skimmer, hose adapter for valve fitting VF15, and then you can see this table. As I just says, four items: vacuum cleaner head, stainless steel brush, telescopic handle, and floating hose and adapter. Thereafter, maintenance equipment. Maintenance equipment wall brush, 30 centimeter long, nylon brush to be attached to vacuum cleaner handle, used to assist wall cleaning where vacuum cleaner use is inconvenient. Then leaf skimmer is a model plastic net to be attached to vacuum cleaner handle used to remove floating leaves and debris on pool surface. And then safety equipment. These three are the we have seen the glimpse. These are here, this is safety equipment. Normally, a pool shall have a safety rope separating shallow area from deeper one. A safety rope assembly should include 3/4 inch diameter of 20 mm USA nylon rope in a length equal to width of pool. Rope floats 25 per meter of rope, 25 per meter of rope, and two hooks to fasten rope in anchors in pool wall. So this again you can see this rope. Then the stable is here, nylon rope, rope floats, and rope hooks. And then a rope anchors must be installed during pool construction. See below deck equipment. So this table you can see small table here is regarding rope. The top should be, and then water test kit. This is a water test kit. Good pool maintenance. Good pool maintenance includes two separate operations: pool filtration and proper balance of pool water chemistry. So there are two things, two issues, separate operations. One is pool filtration and proper balance of pool water chemistry. Pool must be kept in neutral zone between acidity and alkalinity. We know what is that. As measured on pH scale by direct addition of selected chemicals. Water must also be kept free of Algae by addition of chlorine chemical. Use a water test kit daily to identify requirements for chemical in each pool. Model includes test solutions, vials, and comparator color tubes. Kit indicates chlorine standards on a scale of 0.1 through 1.2 and acidity pH standards on scale of 6.8 to 8.2. This is just a glimpse of this test kit. Now go to chemical feed pumps. Chemical solutions required to maintain proper pool water chemistry may be conveniently added to circulation system by use of chemical feed pumps. Chemical solutions required to maintain proper pool water chemistry may be conveniently added to circulation system to recirculation system by use of chemical feed pumps. These pumps are intended primarily to serve as automatic hypochlorinators for handling calcium or sodium hypochlorite solutions. They perform equally well with other chemical solutions such as soda ash, alum, and inorganic acids. Units are of positive displacement, diaphragm type, pump head and fittings are molded or machined from chemical resistant PVC thermoplastic. Capacity of discharge is adjustable in terms of percentage. Maximum suction lift is 1 meter. Motor is heavy duty, lifetime lubricated, 220 volts, 50/60 Hz with overload fuse. Pump includes pump motor, motor assembly, suction filter, inlet fittings and non-return valve and 2 meters of plastic tubing. The complete system, select solution tank and pump mounting. So this is simple diagram. I'll sketch of this. And this is chemical feed pump. Oh, this is this table, chemical pump, solution tank, maximum capacity. This is table only just for information. It's nothing to be technical on that. Yeah. And showers. Single arm stainless shower with cold water tape and food wash tape. Twin arm stainless showers with two cold water tape and two food wash tapes. Available fiberglass shower tape, and you can see this. It's simple. That we all know in plumbing what type of showers are there. It's nothing very new. Then thermometers. TG floating thermometers with blue rubber rings, diameter 18 centimeter, 30 centimeter shaft, complete with plastic cord and snap rings for fitting to edge or ladder, minus 10 degrees Celsius to plus 50 degrees Celsius or 40 to 120 degrees Fahrenheit. This is your thermometer here. Floating thermometer. Then pipe unions, articulated joint, easy to install of multiple use, available either threaded, 1.5 inches gas or smoke, diaphytic glued. This is another sketch, the color black one. Of course, this is sketch there, and then we go to next one, and that is comes then fittings, pool fittings. What are they? I was first look on these fittings. Available stainless steel. Now fittings are constructed of plated, cast bronze chrome plated and polished to meet engineering specifications for use in concrete commercial sized pool with scum gutters. So model description, maximum flow rate, outlet size is given for this, given the table. Model, description, and further details are here. A large speed. There are main drain 12 inches square, then the square grade stainless steel, then square grade ABS material, and gutter, drain, inlet lower, all these are there. No need of explaining them. An MC pump card, complete with ground fault, circuit breaker, and 33 meters of rubber electric cabling. Pump card. Is it sorry? Then let's go with this. Superior one. Well, this is commercial and I will not take this into my okay. Now what it says, stimulating and relaxing action of hydro massage makes a daily routine one of most pleasant moment of day is a part of commercial one. Well, just what about it. Now baths are world of air. Whirlpool baths are a world of air and water to keep you in shape. Method was designed and patented over 40 years ago, so means 60 years ago, 70 years ago now, and gives a perfect mixture of air and water. Jacuzzis, whirlpool jets with their adjustable flows and directional settings really relax. Well, listen to this. So, jacuzzi benefits. Benefit, they'll say something. I'm not going to commercial part of this. Technology, more important. Well, technology. Technology. Three key factors work together to give you a superior massage. First, unique whirlpool action of our patented jets create a brown circular pattern of bubbles as air water mixture flows into your bath, providing a luxurious, deeply penetrating massage. Second, these jets are directionally adjustable, allowing you to direct massage to where you want it. Additionally, you can adjust air-water mixture until it feels best to you for a truly custom massage. Okay, well, this is massage system. You can we'll just see sketch of that pattern to the next simple that it says. And then integral part of one full jets, another sketch is there. So, all right, then, and move further. Now, okay, there's a bathtub in fittings I want to show, which is a very interesting one. And this fitting is a part of it, that's actually very important from technical viewpoint, not from commercial one. See this is very important from coordination point of view, which I am interested in. Means we should at least know something of this system so that we understand what this plumbing guy, this technician, they talk of. And for example, it's given there are so many points up to 1 to 15, 16 here. It says whirlpool jet. Then it says minimum water level for correct operation. Air button to start whirlpool. Air regulation control. Not hot and cold water controls. Then diverter and overflow drain. Hydraulic pump. Air line. Whirlpool line. Whirlpool suction line. Cold water connection. Hot water connection, electric control panel, water outlet, and to be connected to diverter. So it says, and see once again you can see that these are all given here as I just wrote. You can see these numbers are here and all these numbers are here as well. So these are various complicated fittings and now maybe more complicated because more comforts are coming in and this is well, shapes I'm not interested in. Then we'll go further on to that. All these details of bass I'm not showing because these are commercial architectural details here I'm not interested in. I'm interested to think about coordination. That is very important. Now, now I'll talk about something that is that is about engineering or designer, which is very elementary one, of course, but very useful. This is structural design actually. You all know about that, but still for common man it's not known. What says that design dominates structural engineering. There is nothing in structure not defined in design. In exercise of structural design, many talents are needed. Its execution engages many persons, plants, and large sums of money. Heavy responsibilities are undertaken. It's governed by general desire to have what is needed at maximum minimum cost. It's an art concerned with adequate. Its history shows a perpetual extension and refinement of knowledge of what's needed or required of a structure and how need be satisfied at least at least expense of human effort and wealth. This I'm talking about a structural mechanism which actually is not direct design but concept and philosophy of that mechanism which should work perfectly to what we think of. Now, what factors actually should we consider? Function. Structure most fulfill. Structure must fulfill its intended purpose and function for which we are spending money. This may be complex, concerned not only with support of load but with water tightness, thermal and sound insulation, fire resistance, chemical resistance. Actions of load itself may be complex and show not a single it's gone, not a single design load, but a wide spectrum of loads and their combinations occurring with varying frequency. Moreover, as soon as structure is built, it influences of weather, aging, fatigue, use, ill use, accident, and other causes of deterioration commence to act upon it. Designer seeks to ensure continued serviceability of structure during its intended life. Structure must be safe. Most structures involve public. There are few to whose strength someone doesn't at some time entrust his life. Consequences of collapse are grave and possibility of collapse must be remote. Designers' estimate of adequate safety is partly analytical and partly a matter of judgment. Accident-prone structure may be difficult to define but can be recognized by experience. Economy structure must be of least cost. Client having decided, doubtless, in consultation with designer on standard of strength, durability, durability and other qualities that one requires. Design shall proceed with this intention. Designer is in fact in marketplace looking for best value for client's money. Design decisions always implicitly and often explicitly are economic decisions, right down to choice of smallest details. Designer is all too seldom able to consider balance of first cost and maintenance cost. Clearly, each can be reduced at expense of other. Somewhere there must be a minimum total cost. Most owners of structures seem to be so organized However, the two are paid for from different funds and effect of one on other is not revealed. It must be assumed that owners have fiscal and financial reasons for this process of design. Appreciation of requirements. Designs start with appreciation of clients' requirements. This is critical stage in process and calls for closest collaboration between client and designer. Not even not every client knows what is needed, and many are unaware of what structural engineering can provide. No engineer should be more clever than is required. Formulation of schemes. As many facts and factors as possible are collected and assimilated. Mind concentrates upon them, immerses itself in them by some process of intellect or imagination, often in moments of relaxation. Concepts of general structure suggest themselves, sometimes vague, sometimes surprisingly complete. And appraisal of schemes. These concepts are then developed approximately and appraised by design. Amount of mathematical analysis at this stage shall depend upon designer's experience, and often no more is done than is enough to determine general dimensions, and designer is likely to concentrate more on functional suitability, ease of erection, and economy. Good designers are recognized as much by their discrimination at this stage of design as by their inventiveness in previous one. To think of clever schemes is not an unusual ability. To choose between them, to recognize difficulties and advantages is perhaps less common, but not less important. Indeed, more experienced designers, more ruthless, that is, in checking its schemes against problems that designer foresees shall arise on site and in use. These problems themselves shall prompt further developments of designer's scheme. At the end of this appraisal, designer returns to original requirements, perhaps to client. Process may have thrown up unexpected possibilities that modify requirements. Alternatively, what was thought feasible may be found to be no so. Economic aspect may need rethinking. A spiral process of collection of facts, conceptions, appraisal, and return may be repeated several times with occasionally a complete new leap. It may often be only after much labored thought and sketching that quite suddenly simple, obvious answer occurs. Designer must give thought to method of erection right at beginning. If designer fails to do so, construction may be costly or even impossible. There is a dilemma here. Designer should not normally remove from constructor choice of methods, although designer is obliged to assume one in order to be able to develop scheme. In practice, if designer can think of one method, the designer can think of five, and contractor shall frequently invent a sixth. If one can think of none there probably is, but having adopted one method, all details must be consistent with it. A coherent erection scheme shall usually permit of a variant which may then be readily assessed. Moreover, economical job is usually one with a straightforward, clear-cut method of erection with a minimum of separate processes following one another without mutual interference. In considering cost, it's more useful to concentrate on operations than on minutiae of quantities. and rates whose apparent precision may mislead, with choice of structural scheme implying a material and a method of erection, decision of major effect on cost and utility of final structure has been made. Keen analysis shall have only a small effect. Analysis of final scheme. It's now that a full structural analysis is made. This is frequently referred to as design. In fact, significant design decisions have already been taken, and operation of analysis is much more a process of checking scheme for soundness in service and during erection. Clearly, what designer does not know about cannot check. No analysis will tell designer of anything designer is not looking for. Here again, a knowledge of difficulties and dangers to be guarded against is a mark of competence. Details and specifications. Detailing must be seen as an integral and important part of design. It's a matter of which designer cannot afford to lose control because bad detailing can lead to disaster just as surely as a defective oral scheme. In fact, it's much more frequent cause of trouble. Bad detailing can greatly increase costs. It's easy without close supervision for details to creep in which are not consistent with rest of structure and which can render impossible an otherwise carefully considered erection scheme. Specifications are a part of design, complementary to detailed drawings, and not merely a means of regulating contractual relations. These directions to constructor are necessarily complex. One of reasons why innovation in structure is evolutionary rather than revolutionary is that too many unfamiliar features in one job can so overload communication that cost rises and risk of failure increases. Supervision should be under designer's control. Designer's task is not completed when design has handed over. Design has been handed over bundles of documents. Construction is rarely without incident, requiring decision, consequences of which designer alone may be able to appreciate. Philosophy and safety. Philosophy, general. Absolute freedom from danger cannot be attained, no matter how much money we spend on structure, since, however, probability has been found to be a common measure of diverse circumstances affecting safety. Probabilities that a structure shall be under strength or overloaded can be estimated. If gravity of consequences of inadequacy be expressed as an acceptable probability, combined risk of understrength and overload can be compared against it. Practical designer has always varying factors of safety according to designer's estimate, often subconscious, of danger. Current knowledge makes this estimate explicit. It can be analyzed and its separate parts assessed. Margin of ignorance is thereby narrowed and structures may be built of consistent safety. Wasteful overprovision, wasteful overprovision is avoided and more can be built for same money. Strength. Designer's estimate of strength of structure is based on two successive assessments of probability. The first is of a strength of elements of structure as built. No small part of classic, no smart part of classic factors of safety was intended, and rightly so, to cover risk of material being less strong or dimensions smaller than specified. Both these risks, however, are open to assessment by process of sampling, testing and checking. Certain forms of prefabrication permit of so dealing with complete structural members, whilst the method of construction, such as pre-stressing, incorporates an automatic acceptance test of materials. The strength of structural element may thus be expressed statistically, and cost of a program of sampling, testing, and supervision may be balanced against obtainable economics obtainable by a higher probability of adequate strength in structural members. Second assessment is of strength of structure as a whole based on previous estimate of strength of its members. Behavior of structure is analyzed typically at two limiting states: state at which it ceases to be serviceable and state at which it collapses. Technique of analysis available to designers, whether mathematical or experimental, have been highly developed. They are powerful. Judgment is still needed in their use. There is no automatic means of calculating structural strength, and even most refined methods have their own inexactitudes. Now, loading on actions. Much attention is given to understanding of loads occurring in engineering structures. It's regrettable that though many buildings are in fact major engineering structures, loads to which they are subject have not received such attention. Understanding is important. If loading is underestimated, or if some effect of loading has escaped attention, structure is in hazard. If loading assumes if loading assumed is greatly in excess of that occurring in reality, structure is wasteful. It's necessary to know association between value of load and frequency with which it occurs. With structures exposed to wind or wave, for instance, it's often difficult to determine extreme value, and if it's necessary to estimate a maximum value, likelihood of exceeding which is sufficiently small, albeit always possible. With other structures, it's impossible much to exceed load to which structure is permanently subjected. With others, again, combinations of loads may be critical. If, for instance, there are two independent forms of loading, each with a wide scatter, a reasonable estimate of necessary strength may be made only by calculations of probability of occurrence of dangerous combinations. Life of a structure is significant. Longer it is, higher probability of an extreme load occurring. There remains an accident that are likely, such as vehicle striking central pier of a bridge or a motorway. There are those that are credible but unlikely, such as wind velocity, substantially higher than any hitherto recorded. There are those so unlikely as to justify ignoring them, such as a meteorite striking a dwelling house. A design based on probability incorporates all these risks into a rational analysis of safety. Consequences of structural inadequacy. Inadequacy may be of two types. Structure may cease to be serviceable or it may collapse. Acceptability of risk will depend on consequences. Normally, loss resulting from unserviceability shall be much less than that from collapse, though in many industrial structures, interruptions of production places a heavy penalty upon unserviceability. Response of a structure to failure of a member may be one of following. The structure will collapse immediately as with a pin jointed truss. If member of such a truss fails, truss collapses. This is statically determinate or isostatic situation and is that covered by classic factor of safety. A structure shall not only collapse but entrain collapse of adjacent structures, progressive collapses. An example is a masonry multiple arch viaduct, failure of which failure of one arch removes support for thrust from its neighbors, which collapse in turn. Structure may continue to stand, though with reduced strength due to redistribution of load. This is situation of a structure specifically designed to be fail safe and sometimes, but not always, of a statically indeterminate or hyperstatic structure. Practical consequences of these three types of failure will shall vary widely and must be assessed in a given case and set against risk of failure assessed above. Clearly, if failure of structural members leads to a widespread collapse, consequences shall be graver than if collapse were limited to structure of which it forms part. But provided that designer ensures that risk is adequately remote, such a structure may properly be adopted. Multiple arch masonry viaducts do not have a conspicuous history of failure. In practical design, three broad aspects of strength, loading, consequences of inadequacy are expressed by factors relating to each aspect separately. Overall factors against collapse would thus be a function of factor expressing probability of obtaining foreseen strength. Factor expressing probability that a certain load shall not be exceeded and an additional factor expressing consequences of collapse. Now, designer and profession. In practice, designer is not in a void alone with client. Constructors and his conscious structural engineers form a community working within society as a whole, and individual designer may expect to receive aid from other colleagues through professional institutions and learned societies. Aid relevant to this report that designer receives from colleagues acting corporately is as follows: expression of a philosophy of design, accumulation of facts, recommendations concerning sound and tried procedures, evaluation of innovation, assistance in standardizing widely used materials and components. Not all of these functions are beyond wit of individual engineer, and a person of acute and powerful intellect could perhaps dispense with help on most. Nor is there certain sanctity in numbers. An assembly of ill-informed persons can reach only an ill-informed conclusion. Nevertheless, it's clearly to an advantage of all that profession should place special skill, experience, and knowledge of some at disposal of many. So philosophy is needed to formulate rational criteria of adequacy. Lacking such structures are either wildly expensive or stand up, if at all, only by accident. Greatest service an institution or a learned society can offer is to enable a philosophy of design to be elaborated, discussed, confirmed, and developed. Papers are classic means of transmitting experiencing in design and construction, presenting new findings and proposing new departures, all of which form raw materials of a philosophy. Matter of presentation of such discussions, both verbal and written, and make in a forum have been defined. Now, recommendations, design, and procedures. Many structures executed at any time have much in common. If accepted rules of a mature technique whose value has been confirmed by experience may be set out by profession. It will be a help to many. Codes of practice are chosen instruments for this purpose. They consist of a compendium of good practice drawn up by engineers of authority. They are submitted for approval to profession at large before publication. Their drafting, publishing, and amending place a heavy burden on profession. They are intended as a guide for chartered engineers experienced in field in question and combine functions of presenting fact and recommendations for design of discrete structural elements. Overall structural concept lying outside their scope. They are not intended to be mandatory by and large. They have succeeded in purpose described. They have also been successful in establishing a vernacular of sound detailing. Junior levels of profession rapidly become skilled in detailing according to code. Skills gained is not wasted. When junior changes employment, when juniors changes employment, seniors know by and large what they may expect from juniors. Moreover, ability to find a summary guide within small compass is a great saver of drawing of his time. Codes contain both facts and recommendation, and it's important to distinguish between them. Fact is verifiable. Recommendation must usually be accepted on authority. Too much insistence on conformity with recommendations of other persons can screen designer from reality. Loss of contact with reality in any branch of engineering is finally disastrous. Use of codes is dangerous if their function is misunderstood and they are treated not as aids but as complete instructions. Under impulse of economic competition, code is sometimes used as a checklist. Satisfaction of its items is deemed automatically to ensure an adequate structure. This is an illusion. No rules can replace skills and conscience of designer. Too many can destroy them. Accumulation of fact is continual. Presentation, its presentation in accessible form is an uninspiring but necessary task. Many tables of mathematical functions, of structural constants, of properties of materials have become indispensable tool of design. New facts must be similarly collected. Evaluation, everything in engineering changes. Not only do knowledge and methods improve, but needs available labor and materials. Relative costs, all change continuously, all change continuously. Innovation in design is a necessary response to these changes. When new materials, new methods of design, new structural forms arise, they are usually discussed and approved in papers to institutions. It's then, it's then institutions practice to produce reports upon them to facilitate more general adoption. These reports are partly factual descriptions and partly a guide to good practice insofar as it has evolved. They constitute, in fact, preliminary codes of practice awaiting wider experience and approval. A newcomer to a building world is agreement bond which produces temporary certificates for new building materials, devices and components. So just general information is there about that. So you may know all that. Just for those who know nothing about that, it's about designer and society. Now, work of structural engineer are of major consequences to society. which can and should define functional standards of buildings. These standards are expressed in building regulations, which have a large effect in determining general cost of building. Since not all structures are designed and built with professional assistance, regulations contain a mass of detailed requirements whose necessity and value in certain branches of buildings as at present carried out cannot be questioned. It has, however, been found convenient to incorporate clauses which say that structures built in accordance with certain codes of practice are deemed to satisfy regulations. Current practice of profession is thereby recognized as acceptable. There are, however, objections. Codes become in effect mandatory. There's a gulf between recommending an action and commanding it. Codes are explicitly recommendations. Were the profession to draw documents intended to be mandatory, their contents would be different. Codes are guides to engineers experienced in field in question. They are unsuitable for embodiment in regulations which permit design of structures by unqualified and inexperienced. No regulations, however complex or all-embracing, can guarantee safe structures, and rather than by ever tighter rules, public safety will be better served by a clear-cut definition of responsibility. Consideration should be given to developing a way in which such responsibility can be carried out by a person or firm preparing a structural design. Now, there are many forms of contracts which have been revised and new one, and these are old ones I am here. Well, these forms are, you can say, FIDIC is very important. We will discuss that one later on. Also, there is one that is previously used to be Institute of Civil Engineers, London. Now it's different, a new contract it is, and there are many other forms which are very useful. We'll see them later on. Now here is aim of structural design. A good design has certain typical features: simplicity, unity, and necessity. This is very important factor. It says typical features. Good design means what? It says it should be simple, unity, and necessity. Simplicity is common to excellence. In all arts, that impression of ease, which is usually result of intense effort. Structure in which evident difficulties have been painfully overcome lacks excellence. Simple does not mean elementary. Simple does not mean elementary. A structure suited to its purpose and easily constructed may be of great analytical complexity. Unity means a single thing, not just a heap. Unity of a small span bridge will be quite other than of a power station. Both are, but both are formed of separate parts, which are made to serve whole, and if whole and parts are well designed, unity shall be seen. There is a superficial unity which is to be avoided. How easy to avoid the chaos of unrelated parts behind a screen of a bold eye-catching pattern, and how easily and with what disastrous results parts can show tough through. Last feature, necessity, is perhaps key. How magnificent result if there is nothing in a structure but that which is necessary. This is not a paradox. Mind is at least in acceptance of necessity, but is uneasy in presence of wasteful, superfluous, factitious, not that characteristics are to be aimed for directly. There are that by which good design is recognized. They are attained by attained by single-minded pursuit of a specific purpose of a structure. Its function, safety, and economy, a design that satisfies functional requirements practically and economically is least that is expected of designer. Very magnitude of designer's responsibilities, however, imposes on designer ceaseless pursuit of excellence. This aims of a structural design, I have taken this extract from a report of Institution of Structural Engineers. This was in August 1969, UK 2, Upper Belgrave Street, London, SW1 into 8BH for information exchange to readers. This is not my paragraph, just for information. I have taken from that journal. So, for general information to readers, now I'm now moving to something else. This chartered bodies, etc., will take later on because these are very complicated issues and question of engineers and laws are concerned. There are certain laws somewhere and certain laws do not exist. Problem is professionals in our country are not in unison about designs. That is something else. Now I'm now going to field issues which are very important from my viewpoint, and that is about role of site engineers. It's a note I have written. This is now prior to talk about this topic, let us have a brief discussion about term value engineering. Now, what is value engineering? Is it about cost or is it about quantity? Answer is no. It's none of these. It's having entirely a different industrial meaning and a fine understanding of its construction is a must for personal belongings to all relevant parties involved on projects. In civil engineering field, there is no limit on activities in all sections, be it designs, be it construction, be it supervision, be it office work or site work. All engineers would carry out work according to requirements as specified. Contractor would do job to contract requirements. There will be no value on expected level of performance. Quality system shall have to be complied with. Any accountable professional has to carry out job, whatever job normally, but when some job is done based on additional thoughts or research based performance, enriching grade of product in terms of superior quality at cost of normal budget, saving on cost of project, saving quantities of expensive materials, saving contract time based on superior alternatives, excellent methods, alternatives than usual, presenting project with added service life, allowing better use, flexibility on designs, inducing environment-friendly provisions, adding green use capability of building by saving energy consumptions, allowing various other benefits for user or client at same or normal cost without risking safety by thoughtful approach adoption. These benefits amount to value addition on project in whatever form. Project proposals overweigh normal one on or conventional bids. This especially induced quality of performance amounts to be termed value engineering, which applies to all parties involved on whatever project. value engineering is very different. All specialists working on project should add values to project. We'll talk it in details. Let's say honor. What is honor? What is designer? What is contractor? What is quality? Let us see. Honor, this is briefing because we are talking. I'm going to talk about the role of site engineer in brief. So honor has a right to expect best product out of money spent. Honor has a right to expect best product out of money spent. Work should be awarded to a contracting party who corroborates offer to work and produce project with value engineering. Exclusive price comparison is not suggested to be made an exclusive basis for deciding about contract. Designers should produce a best design, making life of all others easy, and contractors should work in such a way that maximum level of quality should be attained with quantity. None of two, quantity or quality, should lag behind each other. Both should move together. Quality. Responsible personnel should encourage executive site personnel to give their best on production more than specification compliance. Quality should teach site personnel for better approach. Quality policing is not required, but quality contribution is required. Now, site engineer. Prior to deliberating role of a site engineer on any job, let us understand what is definition of site engineer. That is very important. Definition in nutshell. Let's say site engineering. Site engineering indicates the chain of carrying out various engineering works, descriptions belonging to all discipline, starting from tender stage to handing over or maintenance stage of any building or structure or project owned by in any sector, government or private or others. This is site engineering, means chain of carrying out various engineering works, descriptions belonging to all disciplines, starting from tender stage or build stage to handing over and maintaining or maintenance stage of whatever building or structure or project owned by whatever sector, government or private others. This is site engineering. Supervision, what is that? On an supervision level, engineers are deployed in capacity of resident engineer to work on behalf of contract engineer. Contractual engineer is man. What is contractual engineer is also important. Contractual engineer is meant herein to an engineer specified or included or defined within legal contract documents. Contractual engineer further delegates executive supervision powers to resident engineer. Within governments or to my awareness, there are 5 categories of engineers starting from chief to junior one. Generally in government like that. Maybe it's changed somewhere, but meaning is same. So chief engineer is originally responsible. Chief engineer is originally responsible for all contractual decisions as head of department. Project should come under authority of chief engineer as a contractual engineer. All further engineers down the line of delegated hierarchy should be described as resident engineer of various levels. Description. Construction and project manager, project engineer. Downwards organization line to foreman, supervisor, charge hand work in any whatever construction contracting company. All these designations are factually responsible for achieving project construction execution. In case project is designated as EPC, that is engineering, procurement and construction, various sections are defined are various sections as defined are integral or integrated to work together with independent authorities controlled under competent coordination. Engineer who represents construction company on actual site or real site is and functionally reports to engineers representative resident engineer on site is designated site agent or site in charge or site manager depending upon contractual requirement. This engineer is designated as responsible site engineer for project. Under EPC, such engineer own, own responsibility of all sections functionally, virtually. Resident engineer and site engineer are considered equals as project site authorities for functional purposes on site organization from different parties. A resident engineer is responsible for all works of supervision carried out on project. Cost responsibilities are owned by engineer and not resident engineer. Final power still is owned by engineer for all contractual purposes. Site agent representative. Site agent representative. Let me see if I can read with respect because I find comfort in that. Let me blow it better. Let me blow a little. I can comfortably read them. So, resident engineer is responsible for all works of supervision carried out on project. Cost responsibilities are owned by engineer and not by resident engineer. Final power still is owned by engineer for all contractual purposes. Site agent representative. Site agent or representative or site manager, you may say, is responsible for all works of constructions carried out by contractor on project. Site agent or engineer posting is formally approved by engineer on resident engineer's recommendations. Approval of site agent can be withdrawn at any time by resident engineer on behalf of engineer. Contractor has to produce another competent site in agent to replace outgoing agent. All engineer supervising engineers report to resident engineer and work for contractual engineers. All site staff of contractor, including subcontractors, report to site agent. Site size, magnitude of project demands number of further site staff to meet requirements. Many site engineers to practically dedicatedly supervise all works may be employed on various sections of projects in many constituted teams under senior site engineers or construction managers. Various sections are organized under QA system or QR system in USA requirements on all projects. Safety, engineering, planning, contracts, construction, surveying, quality, materials, administration are various strong model typical sections established on generally every site. All these sections have relevant details role to perform on projects. Roles are defined in project quality plans. We have to discuss site execution engineers' role in this talk. Broad activities on site, what are those? Let us say, think on site takeover. You are going to construct a site, you are going to construct building on that or something. What you have to do? You have to take over site. Then site planning and site mobilization, site surveying, site start or kick off, site construction, site quality, site supervision, site competition and maintenance. So again, take over, plan, mobilize, survey, kick off, start, construction, quality, supervision, some required, and of course, then you say construction quality supervision after kickoff and site completion and maintenance. Now, this I'm talking of. Actually, I had written this paper some time back when I was invited as resource person on a project, or you can say educational project or training project, which was initiated by government of this country, and that was earthquake management, EQM. What that it was, I just included this on my submission. That is earthquake management involved in general with site engineering, site engineering, site coordination. So this is what it is. And site engineer has no definite independent direct role on EQM, but EQM is earthquake management. So, but indirect role to implement design, engineering, and project decisions to comply with quality. Okay. Then what is this? Complying with quality systems with strongly extended base supports by all responsible discipline sections on project. So what site just says, let me speak again. Site engineer has no definite independent direct role on earthquake management, but indirect role to implement design, engineering and project decisions to comply with quality systems with strongly extended base supports by all responsible discipline sections or projects. And site quality plan and site safety plan. Site quality plan and site safety plan must describe functionary as well as reporting roles of all responsible engineers on project. Both documents are very important, significant to perform on contract project. Maybe many of you know about this quality plan and site safety plan, and maybe most of you do not know this. It happens. Since site agent representative is responsible in all respects for site, role multiplies as follows. What it does, you can say design review. You all know about that. Design review. Of course, nowadays proof checking is done. Even then, we cannot leave it to proof checking alone, because proof checking may be bylaws requirement, it may be regulatory requirement, but to an extent we have to understand that after all are human beings. So design review is first engineering requirement or activity to make sure that design specification requirements have been included within design philosophy. Engineering section performs it. So you have to review design yourself. You are engineer. Then now soil report requires thorough review through engineering section. It is to be made sure that all recommendations included by soil or geotechnical engineer have been covered within design. In case of whatever pinpointed observation, it should be brought to notice of designer through agreed procedures. Should also be specified on design drawings specific value of soil parameters adopted on design. Certain parameters must be confirmed by testing properly, right? So should also be specified on design drawings specific values of soil parameters adopted on design. Certain parameters must be confirmed by testing preferably on site prior to laying foundations. In case localized soil does not allow adopted design parameters, design should be reconsidered. It's responsibility of site engineer to ensure or conducts this task in all major areas of site employing approved laboratory is required in contract. It's required in contract. Site quality engineer. Site quality engineer has to involve for quality certainly of test. Any variation, whatever variation from soil report should immediately be reported to soil laboratory and designer. Actually, soil laboratories are not separate laboratories. Laboratory itself has got means of testing of all. Then resident engineer has to make sure that testing system is complied with in line to standard procedures. All relevant engineers must sign inspection and testing plan ITP for such activity. Testing of all materials. Adopted according to specification, requirements must be made clear, must be conducted to ensure the demanded quality conforming materials. Particularly, the reinforcing bars is an important item for purpose of procurement. Correctly. Concrete trial mix should also be carried out so that right quality required mix from RMC is produced to meet design requirements. RMC, right? And concrete trial mix should also be carried out so that right quality required mix from ready mix concrete is produced to meet design requirement. Piling should be done fully in compliance to specific design and test load requirement. Load tests as well as integrity tests must be rightly, satisfactorily conducted. Connections between piles, cutoff level, and pile caps should be rightly, satisfactorily made. Test piles activity must be conducted much in advance. Site engineer through engineering Site engineer through engineering must make sure that all drawings contain right ductile detailing of reinforcement. In case of whatever detail missing, should raise immediately relevant query for confirmation. Right. So what I say, site engineer, thorough engineering must make sure that drawings contain right ductile detailing because I'm talking of earthquake. So ductile detailing is very important. Of reinforcement, in case of whatever detail missing, should raise immediately relevant query for confirmation. Arrangement must be by right now. It is very significant for proposed materials to resist earthquake forces, which included which included materials means permanently included materials should conform to standards without any adjustments. No compromise should be made in quality of these materials. Generally, Generally, it's RCC that is often included on various buildings and it is certainly considered for design. It's significant to produce concrete works with good quality and no basic, hmm, no batch of concrete should be allowed to be poured unsupervised. Generally, it is RCC that is often included on various buildings and it is certainly considered for designs significant to produce concrete works with good quality and no batch of concrete should be allowed to be poured unsupervised. This is also written in code. You can go and see that. Site engineer must ensure that whatever precautions are required to be taken on site should have been explained to all responsible skilled craftsmen, artisans, foremen, supervisors, and charge hands. Missing information causes quality problems, working problems that leads to NCR, non-compliance report. Once NCR is opened, once NCR is open, that is, it's very difficult to define actually. Site engineer must ensure that whatever precautions are required to be taken on site should have been explained to all responsible personnel. As I said, craftsmen, artisans, foremen, supervisors, charge hand, and missing information causes quality problems that leads to NCR, that is non-conformance report. Once NCR is opened, once NCR is opened, NCR means non-compliance report. All right. NCR, which is non-conformance report, once NCR is opened and issued to site, its remedial action and its closing is a must, or else payment has to be stopped for affected part. Got it? What is affected part of conduct until until NCR is closed after satisfactory preventive measures Solutions. Then closing is a must, or else payment has to be stopped for affected part of contract until NCR is closed. After satisfactory remedial measures is applied. All requirements should be included on relevant method statements clearly. All detailed method statements should be approved ahead of starting activity. Generally, a RCC building may require 20 to 30 standard statements, while there would be certain number of specific activities statements. All approved statements should be followed in true letter and spirit to produce quality work. A quality control must be conducted during concrete pour. These may include slump test, air voids, volumes, concrete temperature, concrete mixing to concrete finishing times. All steel rebars details must be produced in form of bar bending schedule prior to giving to fabricator or fabrication. There should be there should meet requirements to avoid stresses. Localization is not accepted. As far as practicable, overlap should be avoided. Rings or stirrups should be fixed in such a way that hooks do not continue on one side. It should be remembered. It should be remembered that reinforcing bars during earthquake action time change behavior drastically. Bars provided with gravity loads start accepting horizontal shear. Distributed stresses. It should be remembered that reinforcing bars during earthquake action time change behavior drastically. Bars provided with gravity loads start accepting horizontal shear, distributed stresses, thereby forcing beams to work as columns and columns to work as beams. That makes an essential requirement to tightly bind all bars. That is make that makes an essential requirement to tightly bind all bars, column bars. And no bars should be displaced during concrete pour or during vibrator application. All bars should behave in continuity. Vibrators must not be allowed to touch any rebar, any reinforcing bar, and for work anytime, whatever. No over vibration should be allowed. No pulling or pushing of concrete using vibrators should be allowed. Then means no over vibration should be allowed. No pulling or pushing of concrete using vibrators should be allowed. No segregation should be allowed. Segregation, you may be knowing, all concrete must be vibrated in case of void formation. Thorough investigation should be conducted and then remedial measures or actions taken. Alright, only what time we have? See, time also is a very important factor. This time is left. Already 3 hours passed. We have to live. I cannot take more time. 3 hours. So, what to do? No problem. All concrete must be vibrated. In case of voids, formation, thorough investigation should be conducted and then remedial actions resorted to. Proper inclusion of concrete spacers, also called concrete covers, should be made at right locations so that rebars keep intact during pouring activity. It has generally been noticed that this item is neglected by site engineers as well as others. Cover, cover is too serious an issue to be considered. Precast covers, well cured, can be used. Plastic covers, if strong enough to bear loads of foundation rebars, can also be used, but below heavy reinforcement assembly plastic spacers. Right. Then have been experienced. Now, this cover is too serious an issue to be considered. Precast covers, well cured, can be used. Plastic covers of strong enough to bear loads of foundation rebars can also be used, but below heavy reinforcement assembly plastic spacers have been experienced unsuccessful, though not discouraged, if strong enough to sustain required strength during preparation as well as during concrete pouring. I myself have used this, but later on I changed using these spaces below, reinforcing bars of footings because they are heavy steel and these actually depress. So I prefer to use precast mortar or concrete spacers rather than resorting to using these plastic covers below footings. Of course, these are available, but better you do your own because home material is concrete, not plastic. Better to you cast on site your concrete covers and use them using binding wire. That is best one. Formwork should be erected based on correct and safe designs of preparatory works. Safety is of utmost importance. Safety first criteria should be fully considered and implemented. Particularly large suspended slabs, forms, supporting system, scaffolds must be certified by third-party scaffolding system specialist before concrete is allowed to be poured. System should be erected in conformance to design received from specialists based on moments, shear force, etc. Whatever is there. Well, in addition to usual quality control tests such as slump or cubes, compressive strength, additional tests should be considered for cores drilled or taken out from various locations to make sure that site conditions match laboratory conditions for cube testing purposes. Curing is responsible for life of concrete and therefore must be given due care and control under direct command of a responsible staff key personnel. No leniency or worry about cost of water or curing compound or Hessian cloth or polyethylene sheet has to be accommodated. Defects observed after striking forms. should be reported to site engineer and through home to resident engineer for remedial actions proposals. No horizontal planes of weaknesses should be preferred as far as practicable. Concrete pouring should be planned for monolithic concrete actions. Construction joint be agreed in advance for an easy excavation purpose. In case construction joint CJ in emergency required to encounter failure of plant, batching plant, location should be dedicated, decided with an agreement with resident engineer. Wherever required, soil improvement has to be carried out to achieve required safe bearing capacity. SBC, imported desert fill or graded fill has to be used for that purpose. Or limiting liquid limit as well as plasticity index to a minimum value internationally. Liquid limit is restricted to 35%, while plasticity index less than 6. Soil improvement shall be required for areas where soft or weak soils do exist. These weak soils are required to be removed and then placed with good granular materials in layers duly compacted to achieve specified field density. Backfill is one activity that makes a lot of difference on future of foundations. It must be rightly conducted and carried out accordingly. It has been observed that site engineers strive to neglect supervision and save project time by filling thicker layers. It's not a good practice. Backfills should be in good compliance to agreed specifications respecting engineered or structural fill, to achieve 95 to 98% field dry density. General fill can be compacted to 90% field density, dry density. Construction sequence should be correctly followed during scheduling stage. Foundation should be planned as far as possible to be cast monolithic. Columns should be cast first. Beams and slabs should be cast one time monolithic. All corrections should be done to meet requirements. It has to be ensured that proper bands are used in brick or stone buildings that have been required for eco-resistant. Long walls should be inserted with bonding columns and bonding beams, meeting requirement of specification. Infill walls should be taken up for later after completing framework. Connections between columns and walls should be made with proper fastenings. Factually speaking, all constructions activities must be complied with design as well as specifications requirements. No negligence should be allowed. Quality system engineers have to similarly involve to check and examine and inspect all activities by observations in addition of strength. In addition to signing ITP, what I say, quality engineer have to similarly involve to check, inspect, examine all activities by observation in addition to ITP. Then resident engineer should keep an eagle eye on activities Contractual engineer got full right to reject any activity approved by resident engineer. Basically, responsibility is shared by site agent in an overall perspective. Quality products should be a must requirement. During earthquake, whatever surfaces too can break due to horizontal forces which require strong and durable fills around with durable joints. All elements of buildings as well as finishing should be well secured and durable so that during earthquake impact these are not distressed, disassociated or torn out. I will take other points in next talk, and this is very important discussion of role of site engineers and whatever contents were included in that script have been generally completed. I will start new one with field applications that I have taken myself. This role of site engineers and many more topics are there relevant to facilities, methods, executions, and various others management points that shall help all. I shall start one by one so that it reaches you. Of course, this would take some time, but what to do? No way out. If you want to improve engineering field, you have to improve. And if field is not improved, don't design anything better. No use of designs if this is only on paper. If you want to do something, if you want to improve structure, if you want to get full benefit of whatever properties these materials provide, we have to think. It is not my responsibility alone, it is the responsibility of all personnel, engineering, non-engineering, everybody. If you cannot do that, then don't call yourself engineer and don't say I'm in engineering. I feel shame on that. If when somebody does not talk engineering and one is senior engineer, it really, I don't want journals, I don't want seminars, I don't want congresses, all waste of time, believe me. Better do yourself because I don't want photo sessions, no use. What is the meaning of that if we cannot implement something? Well, with this, I close this. Thank you very much, gentlemen.